So this is our visualization of the simulator. You can see I'm getting velocity, heading, and time from the simulation. And if I increase the throttle, then the velocity goes up. I can also change the heading, although right now that doesn't have an effect on the road because making roads curve is difficult. But yeah, that's pretty much it.
Cool. So this is what you would see from the cockpit of the race car. Now, in terms of the hardware side, we can see if I slow the car down, the quick way to slow it down is just to reset the entire thing. It'll reset back to 0. And if I do full throttle, so I'm going to turn this clockwise, you can see there's a lot of traction control pulses happening there like before for a mid-semester demo. But once you get up to full speed, they're going to go away. So now they're gone. So the car is now accelerated to its full speed and they're gone. The other cool thing that that we've implemented since is a torque split. So I'm going to put it into mid-throttle about, and I'm going to hit the steering, and you can see how as I steer, the torque is split between each wheel. So on the top you have like the left wheel, on the bottom you have the right wheel, the amount of torque going to each wheel, and you can see how as I turn this, the amount of torque changes based on the steering angle. We also implemented these I guess tachometers for the simulator, which is over here, and then that's the actual controller itself, which is inside that car over there. Same code. But instead, and we have these tachometers. So this is running at 2 kilohertz, and this is running at 4 kilohertz. So our simulator is running at least twice as fast as our actual controller in order to ensure an accurate simulation. So yeah, so that's our 18549 senior project. Hope you enjoyed. Anything else we have to add?
I guess we could look at the car more
Oh.
closely because that's probably
Yeah, the car. Sure, yeah, we can take a look at the car. So here's the car. It's being. Sure, yeah. It's being worked on currently, so a lot of this is a lot of other people's work as well. But yeah, it's quite a ways to go. The steering wheel. The idea is that the driver can control the steering wheel using these knobs and the button to adjust the parameters of the traction control algorithm to the driver's liking, since every track is different, every driver is different, and the road conditions will be different in every race. You have your accumulator boxes here, so basic fancy word for batteries. So these are actually high voltage. Each needs 150 volts connected in series. In the middle you have a high voltage distribution box. Right now it's kind of empty now because it's missing the battery management system, which sits over here. The battery management system. And then more high voltage electronics here in terms of installation monitoring, DC-DC conversion, like this active light, 2 circuits for redundancy. This is basically the entire team's work. The 2 motors are inside this scatter shield box for safety's sake, because the entire outside casing spins, so they're stored inside there. And then it's a gear ratio, it's geared down 2-to-1, so that we get more torque on the wheels. Electrically, we have 2 motor controllers as a result. They convert the DC into 3-phase AC for the motors. We have 3 wires here going into each motor, and as well we have the other motor controller. You can see there's 2 wires going into it for the DC. You can charge the car from the port right here. You can plug in a wire and charge it. You can access the BMS through this guy over here, as well as, but pertaining to our project, you can use these USB ports to program the Arduinos on board the car. There's one for data logging, and then there's one for the actual traction control. So yeah, if you'd like to see more about this car, how we did, go to CarnegieMellonRacing.com. Otherwise, yeah, is there anything else I'd like to do? Oh, yes. This guy over here, which is the main control board of the car. So this is one of the newer iterations. It's not done yet completely, so we have these probing wire soldered on. As you can see, there's two Arduinos in the back, and it uses the D-subs. Here's one of the older iterations they're working on inside the enclosure. So, yeah, it's a very tight enclosure meant to fit under the confines of the firewall. That's the enclosure, and this is the newer version. It's much cleaner, and it's going to go on the cars pretty soon. So yeah, so our code actually runs on this main control Arduino over here, and then it interfaces with all the sensors and so on, which are scattered throughout the car. Yeah. Missing.
I think that's it.
Okay.
All right. Thanks for watching.